Welcome back, Chemistry Theory. This is part 2 of the booklet 16.2. So we finished off number 5. Here's number 6. Explain what is meant by system and surroundings and how they're related to the universe. So system is where the reaction is taking place, the part of where the reaction is being studied. Surroundings is everything surrounding the system, and together they make up the so-called universe. So it's kind of an egocentric way of looking at things. Your reaction is the only important one. Everything else is surroundings. Together they make up the universe. So if we look at endothermic and exothermic reactions, again, endothermic means heat is coming from the surroundings to the system. Heat is entering, so sometimes we think of heat as being gained or it's positive because it's entering our system. Whereas exothermic, heat is leaving our system, going to the surroundings, it's exiting, we're losing heat, so quite often we think of heat as being a negative value because we're losing it. We can't determine the heat content directly of something because it depends on many factors being not fully understood, but you can measure changes in heat. Heat lost or heat gained during a reaction or a phase change, for example. So we'd have to do an experiment to figure out how much heat is lost, and then that would give us an idea of how much heat a substance has or how much energy something has. Enthalpy is basically the heat content of a system at constant temperature and pressure. It's given the symbol H, so you can think of it as heat. And enthalpy of a reaction, RXN is short for reaction here. The change in heat content when some reaction occurs, whether it's a chemical reaction or a phase change. And we can get an idea of heat content by looking at changes in temperature and relating it to how much substance we have and what the substance in fact is. 2 ways in which we can look at it. If it's a physical or phase change, there's nothing chemically changing there. It's just simply the final enthalpy value minus the initial enthalpy value, so after minus before, or if it's a chemical reaction, products minus reactants, after minus what we had before. And looking at, I kind of mentioned this already in terms of signs, for an endothermic reaction, we think of heat entering the system. We have to add it in for the reaction to happen. So if it's a chemical reaction, reactants, we must add heat to the reactants to make products. So we think if heat is being positive because we're absorbing it, we need to add it in to make the reaction occur. So to make this reaction, it has to suck up heat from somewhere else to make their products. So that means that the products contain a higher chemical potential energy than the reactants, so we need to get that extra energy from somewhere else. Just like if you're buying something that's $50, and if you have $40, you need to add in $10 from somewhere else. If we look at exothermic reactions, we think of heat as being lost, we're releasing it, so it is on the product side here, it's being produced. We think of it as being negative because we are in fact losing it out of the system, and that is a way we can look at that. So we can think of it as, okay, we have $50, we want to buy something that's $40, so we have an extra $10 left over, which we can give to someone else or use it for something else. Another way we can look at endothermic and exothermic reactions, so in terms of an equation or positive or negative values, look at it as an enthalpy diagram. So for example, endothermic, we need to add heat into it, so we can think of reactants having low potential energy, as I mentioned before. We have to add in extra heat to form the products that have a higher stored energy amount. Exothermic, vice versa, we have high energy reactants forming products that have a low energy. They don't need that extra energy, so the extra energy is released. As you can see by the negative sign, losing the energy because we don't need it. We're forming products that have a lower chemical potential energy than the reactants. Okay, so that leads us to the vocabulary here. Excuse me, we have calorimeter, an insulated device for measuring heat absorbed or released. Could be something as simple as a styrofoam cup or something a thermos or something more complicated. Thermochemistry, the study of heat change in reactions. So the idea that heat lost is equal to heat gained by something else, and then manipulating that equation. System, where a reaction takes place. As you can see, surroundings is surrounding the system. Surroundings, the area around the system. And then, of course, the universe contains both of those together, the system and the surroundings combined. Enthalpy, the heat content of a system at constant pressure. So all substances have stored energy that can be changed to heat. And enthalpy of a reaction, or heat of reaction, the change in enthalpy during a reaction. So chemical reactions can gain or give off energy. Okay, that is it. So that's booklet 16.2. Stay tuned for 16.3 in a bit. See you later.